So, okay, next topic is thermodynamics. নেই দিয়ে দেবো কি আছে? So thermodynamics is the next topic. So that is our chapter 2. First of all, system surrounding boundary. System is wherever we give our attention, that is our system. It can be anything like pen, paper, it can be duster, board duster, it can be computer keyboard. Wherever we confine my attention is my system. Right? Now, suppose we are doing some work into computer. Now, this computer you have hardware and software. So this software what I am doing, that is application. This is the machineries, but what we are doing, that is the application. Software is the application. So here that we call process. The application part, the software part, that we cannot hold by hand, that is process. System we can just handle, we can touch. System we can touch. Okay, if some water is boiling into beaker, the water, we can touch everything. So these are all system. But the boiling phenomena we cannot touch. Boiling is a phenomenon that we cannot touch. We can touch the water, we can touch the beaker. So this is system. And that is happening, whatever happening there, that is process. So boiling of water into beaker is a process, and there system and process. And apart from the system, whatever you have in the vicinity, that is surrounding. Okay? And in between the system and the surrounding, what we have is called boundary. System and surrounding, in between what we have is called boundary. Boundary wall. Types of system: open system, closed system and isolated system. That is very common. For us, we are living being, we are open system. Open system means energy and mass both can be exchanged. Wherever the energy and mass both can be exchanged with the surrounding is called open system. Like like us. What we are doing, we are inhaling, we are exhaling, the air mass we are taking in, we are releasing that. We are and when we are releasing the air, along with that we are releasing some heat also. So energy and mass, obviously both are exchanged always. For us, for boiling water into a beaker also, open beaker, some water is boiling. So that is also a process happening, and the system is open system because this vapor is going out, that is mass, matter is going out, and heat also taken from the surrounding. We are using the burner. So the heat is supplied. So this type of system is called open system. Closed system means with certain lead, we can make the lead so tightly fitted that the this matter cannot come out. In that case, it called the closed system. For example, pressure cooker below, whenever the CT is not there, means before that, we are boiling the water into pressure cooker, okay, but the steam has not come out yet. So up to that situation, it will be called closed system because it has got a lead, and the mass is not exchanged, but only heat is exchanged. That only the energy is exchanged, but mass is not exchanged. Then it is called closed system. Then you have isolated system. Isolated system means neither mass nor energy can be exchanged. For example, thermoflask. Very close example will be thermoflask, and perfect example not available because leakage will be always there. Thermoflask also there is leakage. Whatever lead we give, there also will be leakage. But just ideal situation if you take. So there are three things: open system, closed system, isolated system. Okay, so that's it. Isolated closed system. Then you have isolated system, as I already told. Then certain property. These are some introduction topic. So that's why just basic some definitions I'm discussing now. Properties of a system: intrinsic property and extrinsic property. Intrinsic property means independent of mass or quantity. For example, if you take one cup of water and one bucket full of water, For both the water, the surface viscosity, specific gravity, viscosity, all these parameter, surface tension, all these parameters will be same. Whether you take one glass full of water or one bucket full of water, it will not vary. Surface tension will not vary. So that is called, whenever it will be constant, means same. Whether you take small quantity or large quantity, the parameter is not changing. It is called intensity property, independent of mass or quantity. Independent of mass and quantity. That is called intensity property. On the other hand, if the property gets changed with quantity, then it is called extensive property. For example, volume. Volume depends on quantity. 1 liter, that if you take some 10 kg of water and 20 kg of water, obviously volume will vary. With the same time, obviously other condition remaining constant, it will vary. So that type of property is called extensive property. Specific properties. Specific properties means per unit mass. Property per unit mass. For example, specific heat capacity. Specific heat capacity, molar heat capacity. Specific heat capacity per gram, per unit mass. That is specific. And if you take it for a mole, then per mole. That is also specific. If it is make it specified, then specific. State and equilibrium and process. State. How many states of matter you know? 5. Solid, liquid, gas, plasma and Bose-Einstein condensate. Total these 5 states. But this Bose-Einstein condensate is a artificial one. Other 4 are naturally available. Which state is maximum available in nature? You think? Plasma. Plasma. Because plasma, suppose sun, if you take all the planets together, much smaller than sun. You take all the other stars, situation is everywhere the same. All planets together will be always smaller than the star itself. Right? So that way, if you take all the galaxies, all the stars, they are all plasma, much larger quantity. And the next will be gas. After plasma, second one will be gas. Then liquid. Liquid will be very less. Liquid is very less. And solid also less. Like rocky planet. In the solar system, how many rocky planets you have? Mercury, Earth, Mars and Venus. That's all. Others are all gaseous. So that way gases are more compared to solid. Anyway, so that is about state. What is phase? There is a very related term. Sometimes we think it is equal. State and phase. Phase is actually not same. For example, you are heating some matter like wax, the paraffin. You are heating the paraffin. What will happen? Initially it will become softer. Slowly, if you give more and more heat, it will become more and more soft, and then it will melt and flow. Right? So, stepwise, it will become softer and softer. But specifically, you cannot say that like a solid, liquid, gas, there are multiple number of phases possible. Another good example, I remember, sulfur. Sulfur, how many different allotropes you know? Allotropes of sulfur? So many are there. One is called alpha sulfur, beta sulfur, mu sulfur, plastic sulfur, isn't it? Colloidal sulfur. Different are there. They are all phases. But if you ask this alpha sulfur, beta sulfur, both are solid. So if you say the state, both are solid. But phase wise they are different. Alpha state and beta state both are solid state. But phase, if you say alpha is one phase, beta is another phase. Diamond, solid. Okay. Graphite, solid. But all are carbon. All are carbon solidified. But these phases are different. Diamond is one phase. Fullerene is another phase. Graphite is another phase. But all are solids. So that way phases are numerous in number. States are very limited. Only 5 states are known. Okay. So states phase I clarified. Equilibrium. What is equilibrium and what is steady state? Equilibrium is like a reversible reaction. If you consider reversible reaction, for reversible reaction, what is seen? Just forward reaction and backward reaction both are occurring, and if the rate of forward reaction and rate of backward reaction is equal, then what do you get? It is called equilibrium. That situation is called equilibrium. When the forward and backward reaction is just become equal, the system is said to be in equilibrium. But what is steady state? See a river, water is coming from mountain and is going to the ocean, but the more or less the height of river at a particular time is for certain period of time, maybe for 15 minutes, 20 minutes, it will be same, na? So that is steady state condition. I just ignore the high tide and low tide situations. If I ignore the high tide, so what I mean to say, flowing in, going out, in and out occurring at the same quantity. The same quantity of water is coming in and going out. This situation is called steady state. That is the difference between steady state and equilibrium. Steady state means there is a flow, but the quantity more or less is same always. That is steady state. Like river is always steady state condition. If you just ignore high tide and low tide, or seasonal variation, forget about that. Because I am talking about all theoretical ideal conditions. Okay, ideal conditions. There will be variation always. State equilibrium process. Now process. How many types of processing? There are multiple processes, and that's the last of this topic because I have another subject, environment, after this. So what is the process? Process can be isothermal, isobaric, isochoric, reversible, irreversible, different type of process. Irreversible process that cannot be reversed easily without any loss of energy. Anything can be reversed, but you have to spend a lot of energy. Okay, like water is falling from the rooftop to the ground. It is falling down. If you allow it to flow, it flows down. That is spontaneous. Can you make it back to the rooftop? Yes, we can with pump. So we have to apply certain energy, right? It's not automatic. It is not automatic, but you can by using pump, you can get the water back to the place. Carbon you are burning, producing carbon dioxide. Can you make it back? Yes, we can. We have to apply energy. Okay. So this type of process where a lot of energy required to make it back, these are all irreversible. Irreversible means it will not happen by itself. It is irreversible means it is not impossible. Possible by some other means, maybe very difficult step, not so simple. And reversible means it can reverse back by itself. How? You are melting ice into some container. You just drop temperature a little bit, it will back to become the ice. It will automatically become ice once again. It was ice, you are allowing the heat, supplying the heat, ice will melt and become water. You again cool the system, it will become frozen. Again you are getting back the ice, and it is quite easy. It is not very difficult to do. And when the step is very small step, means little bit of heat given and little bit of ice is molten, then freezing is also equally easy. So what I mean to say, if the step is very small and gradual, then the reversal is also very easy and gradual. So that is called reversible process. That means it will happen in a very slow and minute stages, multiple steps, and steps are very, very small. So that reversal is very easy. One crude example, we have staircase. So many steps are there. If the steps are very, very small, you can climb down and you can climb up also easy. But if the steps are large, climbing down and climbing up, both are equally difficult. That is irreversible. Very crude example to make understand what is reversible and irreversible. If you have a very small steps, you can easily come down and come up. That is reversible or close to reversible. And if you have very large steps, it will be reversible, not so easy to reverse back, so it will be irreversible. Isobaric means pressure constant, isochoric means volume constant, isothermal means temperature remaining constant throughout the process. Okay, so this is called process. So up to this today. Next we will go for environment.